So the myogenic stretch reflex to control GFR or to regulate GFR and keep it within 180 liters per day, no matter what the blood pressure is, that is no small feat. And it's just one strategy. So there's another whole strategy, and this one is called tube glomerular control. And tubulo makes you think of the nephron tubule. Glomerular makes you think of the blood supply. So this is a working together, a strategy that the nephron and the blood supply are going to work together to utilize. Okay, and it involves somebody called the juxtaglomerular apparatus, but of course. So the juxtaglomerular apparatus. And who is this juxtaglomerular apparatus you speak of? Well, let me tell you. First of all, it has to do with, well, maybe I'm just going to do it. It has to do with the glomerulus. So we'll draw my glomerulus with my afferent arteriole coming in and my efferent arteriole going out. And remember how, yeah, this is the glomerulus. Sorry about that. Remember how I drew my Bowman's capsule was like a this, right? And then we had proximal convoluted tubule. Oh, dear, whatever. We ended up going down this way, and then we came back around. And remember how I had ascending loop of Henle come up through this space right here? Do you remember that? Please say, of course I do, because of course you do. This is an anatomical reality, that there is this location, and I'm drawing the cells that actually line the tubule. This is most likely distal convoluted tubule, and distal convoluted tubule comes in contact with the cells lining the afferent and efferent arterioles. Now, we've got some names to do. These guys are called juxtaglomerular cells, and those are cells of the afferent and efferent arteriole. These guys are called macula densa cells. And macula densa cells are part of the tubule. And here's the scoop. Macula densa cells are magic. Okay, they're not magic. They're just physiologically phenomenal because they monitor the filtrate. This is distal convoluted tubule. This is the filtrate that started out in Bowman's capsule, went through proximal convoluted tubule, descending loop of Henle, ascending loop of Henle, and is now in the distal convoluted tubule. A lot of stuff has happened to it. In the next lecture, we're going to look at all the stuff that can happen to it in that time. Macula densa cells monitor that fluid, and if they detect characteristics of the fluid that indicate low blood pressure, they are going to send a message to the juxtaglomerular cells in the afferent and efferent arterioles. Did you follow what I just said? Stimulus, low blood pressure. So I already put the one right here. Message gets sent from macula densa cells to juxtaglomerular cells. Juxtaglomerular cells are going to do something amazing. They produce a substance called renin. Renin is dumped into the blood. Here's renin. juxtaglomerular cells, busted it out, and barfed it into the blood. Renin is an enzyme, and it is going to come into contact with a substance that's already in the blood, just hanging out. It's a protein, and I'm going to make my protein purple because, you know, all proteins like to be purple, and it's called angiotensinogen. Angiotensinogen. Angiotensinogen is a plasma protein that already is just floating in your blood. So out there in the body, you have angiotensinogen, and it's just floating out there. But only if renin gets produced will angiotensinogen get changed into something else. If renin is produced, then renin is going to take angiotensinogen when it comes in contact with it and turn it into a substance called angiotensin 1. Okay, did you follow that? Renin is the enzyme. It gets produced because of low blood pressure. It gets produced in the nephron. It gets produced in the glomerulus. Gets dumped into the blood. Renin goes out and finds angiotensinogen, which is just a plasma protein already floating in the blood. Angiotensinogen, when in contact with renin, gets turned into angiotensin 1. Angiotensin 1 does nothing. It floats around. It continues to float around in the blood until it comes in contact. Oops, the number 6 comes after the number 5. It's going to come in contact with an enzyme called ACE. It's another enzyme. And this is awesome. ACE turns angiotensin 1 into angiotensin 2. Angiotensin 2. Angiotensin 2, doggies, is the action-packed dude of ever. Go ahead and speculate. If you wanted to increase blood pressure, what are some strategies you might employ to do that? Angiotensin 2 probably does it. Number 1, angiotensin 2 is a power-packing vasoconstrictor. What's that going to do to blood pressure? It will increase blood pressure. It is going to also, it's going to make you thirsty. What's that going to do to blood pressure? If you drink fluid, that's going to increase blood volume, which is going to increase your blood pressure. It is also going to increase cardiac output. So it's going to increase the stroke volume and heart rate, which is going to pump blood more effectively through your body and increase blood pressure. Angiotensin 2 will increase your blood pressure. Okay. How about drugs called ACE inhibitors? Yeah. Think about that one for a phenomenal exam type question. What is an ACE inhibitor? What will the outcome be for a drug whose mechanism is to inhibit the ACE enzyme? What will happen? I will let you contemplate that, and hopefully we will talk about it in class. All right, rock stars, see you for part 2 of kidneys later. Bye-bye.